Now we will see each and every component inside the expansion of ideal gases apparatus model TH172 in a detailed specification way. Let's get started with first the Boyle's law. In the Boyle's law, here you can see we are having a glass tank which is made up of a borosilicate glass having a temperature range of 0 to 250 degrees Celsius. Now this glass is having a specification height of around 560 mm and the diameter is around 220 mm, which is 8-inch NB. This capacity of the glass tank is around 25 liters maximum, which you can fill it with the industrial oil, and for the calculation part you can use the medium as a air. This oil tank is connected with top and bottom enclosed structure with the SS304 flanges. This flanges on the bottom side and the top side is situated with these legs on the base panel. This top flange is consisting of one level sensor which is of capacitance type, and this is having a probe of maximum height 540 mm. This capacitance level sensor model is SC701 and range is around 4 to 20 milliampere for the electric signal, and for the calculation part the range is around 0 to 540 mm approx. Now beside this we are having one pressure relief valve. This pressure relief valve is made up of SS304 and is connected on the top flange because it is for the safety purpose. Whenever the oil inside this is keep on going with the help of the compression part and it is filling up, it is building some kind of a pressure. So as the borosilicate glass is having some temperature range and it is also having some pressure range. So the pressure range inside it is around 0 to 6 bar, but for beyond 0 to 6 bar we are having some, you can say, safety purpose. We have connected this pressure relief valve. As beyond the pressure it is directly open directly. Now we will come to the next component, that is our pressure transmitter. Now this pressure transmitter is having a range of 0 to 4 bar gauge pressure and the electric signal output is 4 to 20 milliampere. It is connected with this coupling of 1/4-inch BSP threading on the top flange. This pressure transmitter and this level transmitter which is sending the signal directly to our DAQ model, and this DAQ model directly compile with our application. Last one, the component, that is electric component, temperature. The temperature is having a temperature probe that is named as PT100. PT100 is having a 100 ohm resistance and the temperature range is varying from 0 to 400 degrees Celsius. You can also calculate in the Kelvin just a difference of parameter, or you can say the difference of dimension. Now this temperature also connected with our DAQ model for calculating all the parameters inside the glass tank. Now the heart of this glass tank, or you can say the experiment of the Boyle's law, we are having a sump tank. Sump tank is beside this panel, front panel. Now the sump tank is connected with the SS piping. As you can see from the behind of this panel, one SS pipe is coming and it is connecting with the bottom flange of the glass tank. Now this bottom flange is already connected with the SS pipe, but for controlling the flow of the oil we are having one SS304 ball valve. This ball valve you can operate with the help of hand manually very smoothly. Whenever you have to fill the oil, just open this ball valve, and whenever you have to close the experiment, you can say end the experiment, you just turn on the ball valve. Now this oil is coming from this sump tank, but the sump tank is developing some pressure. So that pressure is building because of the vacuum or compressor pump. Now this vacuum or compressor pump, as you can see, a very tiny pump, but it is a very boosting pump that it is already connected with our 5x2A valve. The 5x2A valve structure is behind this front panel, but as you can see, say one lever is coming here. This lever will actuate as a manually. As you can see on the notation of the right hand side of the lever, the upper side is a vacuum and the lower side is a compressor, and on the middle it is off. So now you understand, with the help of this compressor or vacuum pump we can perform both the experiments, like you can say reverse way also in the Boyle's law. In the vacuum part also you can go for the Boyle's law, and in the compression part also you can go for the Boyle's law. This we will understand in our experiment part further. Now we will start with each and every components connected with our Gay-Lussac's law. As you can see, in the Gay-Lussac law, we are having one tall heighted glass tank which is having a capacity of around 15 liters and the height is around 800 mm. This is having a diameter of 150 mm and it is already enclosed with SS304 flanges from top side and from the bottom side. Now, inside this glass tank, as you can see, one U-type air heater is fitted from the bottom flange and it is connected with the electrically with a manual switch. Now, whenever we operate this switch, electric signal will directly goes on and the heater will on. For calculating the parameters on the top flange, we are connected temperature sensor. These two temperature sensor is same type, same specification as we have connected in our Boyle's law, that is PT100 type 100 ohm resistance and the range is from 0 to 400 degrees Celsius. On the beside of this, we have connected the pressure transmitter of same thread with a coupling 1/4 inch BSP and is having the electrical output of 4 to 20 milliampere, and for our calculation part of a mechanical pressure, the range is from 0 to 4 bar gauge pressure. Same way here, we are connected with the pressure relief valve because both the glass tank is containing some pressure. So for the safety purpose, we have connected pressure relief valve made up of SS stainless steel 304. Now, let's just come to the experiment process, or you can say some basic idea about this. We have connected this heater, and this heater, as you can see, we are having some temperature controller here. Now, this temperature controller is for the safety purpose, as whenever we start the heater for the experiment, the temperature will rising, and as the temperature rising, the glass tank temperature also rises. But we have to say for the safety purpose, the glass tank we cannot go beyond 150 degrees Celsius. The maximum temperature range is 150 degrees Celsius. So you can set here, now already I have set around 100 degrees Celsius. Manually you can set the range 100 degrees Celsius or whatever you can, whatever you want for the experiment. And whenever the experiment perform, the temperature will rise. The set temperature is 100 example. So when the temperature inside this medium air reaches around 100 degrees Celsius, automatically by electrically circuit, the signal for the air heater directly cut off. And when the temperature will decrease, automatically with the help of the electric signal, the heater will turn on. So the advantage of this temperature controller is for the safety of the Gay-Lussac's law.